black holes, where time itself stops. Of all the places in the universe where physics breaks down, black holes are the most famous and the most extreme. A black hole forms when a massive star collapses under its own gravity, crushing all of its matter into an infinitely small point called a singularity. At this point, our equations produce a result that makes no physical sense: infinite density, infinite gravity, infinite curvature of space-time. Einstein's general relativity, our best theory of gravity, simply stops working here. But that is not even the strangest part. At the boundary of a black hole, called the event horizon, time itself slows down to a crawl. From the outside, an object falling into a black hole appears to freeze in place and slowly fade away, never actually crossing the horizon. Time does not just slow down near a black hole. Near the singularity, it stops completely. Physics has no answer for what happens next. Neutron stars. Matter pushed beyond its limits. Imagine taking the entire mass of our sun, all of it, and compressing it into a sphere roughly the size of a city. That is a neutron star. These objects are so dense that a single teaspoon of neutron star material would weigh approximately 1 billion tons on Earth. At this level of density, atoms themselves can no longer exist. Electrons are forced into protons, creating a solid mass of pure neutrons packed together so tightly that normal physics becomes meaningless. The pressure inside a neutron star is so extreme that our current equations cannot accurately describe what matter even looks like in that state. Some neutron stars spin hundreds of times per second, called pulsars, emitting beams of radiation with clockwork precision. And some neutron stars, called magnetars, have magnetic fields so powerful they could strip the iron from your blood from half the distance to the moon. The Boötes Void, a place where nothing exists. In 1981, astronomers discovered something that should not exist according to our models of the universe. A region of space approximately 330 million light-years across, containing almost nothing. No galaxies, no stars, no gas clouds, just emptiness. This is the Boötes Void, the largest known void in the observable universe. According to the standard model of cosmology, matter in the universe should be distributed relatively evenly on large scales, clumping into galaxy filaments and clusters. A void this large simply should not have formed in the time since the Big Bang. The universe is not old enough to have produced an emptiness of this scale through normal processes. Some scientists have proposed it formed through the merger of smaller voids over billions of years. Others have suggested far more exotic explanations. A small number of researchers have even pointed to the Boötes Void as possible evidence of structures we do not yet understand or cannot yet explain. Quasars, the brightest and most violent objects in existence. At the center of some distant galaxies, something extraordinary is happening. A supermassive black hole, containing the mass of billions of suns, is consuming surrounding matter at a rate so violent that the energy released outshines entire galaxies by a factor of hundreds. These objects are called quasars, and they are the most luminous, most energetic, and most powerful objects ever discovered in the universe. A single quasar can release more energy every second than our entire Milky Way galaxy produces in a year. The jets of radiation and plasma shooting out from quasars extend for millions of light years into surrounding space, reshaping entire galaxies around them. What makes quasars a place where physics is pushed to its limit is the environment at their core. The temperatures, the densities, the magnetic fields, and the gravitational forces all reach values so extreme that no laboratory on Earth could ever come close to replicating them. We observe them, but we cannot fully explain them.